Hey, last summer I had made a video about 3D printing a chess piece. Recently, last semester, I have made another chess piece, but this time it was made through subtractive manufacturing. So, what does that mean? Subtractive manufacturing is more often than not, I believe, done through a CNC mill. So a CNC mill is where you have a block of metal or plastic or wax or whatever. Then you have a computer numerically controlled CNC mill, so it can switch bits and drill holes and route out shapes and stuff. So you program it to sculpt a shape out of a block, kind of like an artist would make a sculpture out of marble or something, but a computer switches bits and does it all for you. There's a special computer software that helps you do this and programs the machine for you in order to do this. So I did that this semester. Okay, so do you remember how I said that the queen was hollow? Because I 3D printed it, I had to make the walls an 1/8 inch thick or smaller, but the width is the width of the base is a lot wider than 1/8 of an inch, so I had to make the part hollow. So let me show you what the inside looks like. Isn't that cool? So that's what the inside looks like. Here's the hole at the bottom, and because it's 3D printed, this is almost exactly what it looks like inside. Isn't that cool? So in making the king that you'll see in blue, and note that because of the glare, you cannot see all of the details. It actually did come out a lot better than it looks. But in order to create that, in order to manufacture it, what we had to do was change the geometry. So what we wanted to do is take this queen here and just kind of reuse some of the geometry, but make it manufacturable from a CNC milling standpoint. So we had to make it so it was not hollow, because we could not do that with CNC milling. And with the machine that we had, we could not do this head here on the queen, but we could use the base, the external constraints of the base for the base of the king. So let me show you a comparison of the queen to the king. Let's see here. There we go. So look how similar they are. How about that? Yeah, because this internal geometry right here, not only on the inside of the base where it's hollow, but also this top would be very difficult, actually impossible, to manufacture with CNC milling. CNC milling is a subtractive process, so this king here literally came out of a block, a cylinder block, and I will go into that later how we did that. But this 3D printed queen basically was created out of thin air. Just layers of plastic were layered on top of each other and fused together, and there you go, you have your queen. But here, yeah, we could only twist it around and kind of use bits, drilling bits, to kind of route out the shape. So of course this is solid, not hollow, and it's fairly easy to manufacture this from the outside and you know, around the exterior, rather than, well, making it almost from the interior, creating, you know, a hollow surface inside and whatnot. So if you were wondering how the CNC mill sculpted the chess piece out of a block, a cylinder block, I will show you. So here's a sped up version of how it was done. Trine actually has a CNC mill, and this is what we watched happen right in front of our eyes with our own G code, it's called. We created the G code in a program called Solidworks. In Solidworks, you can not only make the solid model, which I showed you in the last segment of this video, where I was showing you the queen and the king together. You can create those solid models, but you can also, well, another function of that software is you can do Solidworks Cam, which creates G code, which is what you're seeing now, basically. And then you can put this G code into the CNC mill. The CNC mill will follow all the codes. That's why it's called computer numerically controlled. That's what G code is. And it'll follow all the steps and dimensions and numbers and stuff, and it'll create your part, as long as it's manufacturable, of course. But yeah, this was our final exam. It was about 25, 30 minutes long, and we you know, we watched the mill create our part. It was interesting because this is kind of different from what happens in the lab, actually, because in the lab it's not only slower, but you'll hear all sorts of weird noises. It's called chatter, where there's this buzzing noise because your part, your plastic or your wax or your metal part, is vibrating because of it being, you know, routed on, drilled on. And so it's kind of loud, actually. It's very interesting, though, to, you know, just press a button and the machine does all the cutting for you. It's really interesting. And now here it's finishing up the head really quickly here. And so there you go. That's what it looks like. Now, yeah, of course it's not perfect, but this is like precisely what the actual part looked like that you saw in the glaring picture, you know. So the picture, you know, it showed some glare around right here, and that was actually semi-accurate. But when you hold it in your hand, it's actually, you know, this software exaggerates the excess material, so it's actually a lot smoother than this is, but it's showing that it's emphasizing those that excess material because it's like, hey, I want to help you be perfect. Well, you know, who knows if you actually can be, or at least not without like lots of hours of milling time, where your part is being milled for hours. The milling machine will actually have an accuracy of, like, I think it's something like 0.0001 inches. So that's 1/10 of a thou in machinist language. But that's, I think, let's see, what would that be? That would be, so 1/10,000th of an inch, I guess, is the accuracy, 0.0001. Sorry, a little engineering there. But yeah, so sadly, my partner took the part, so I couldn't take it home. It was his turn to take the part technically, so he took it. And I was like, you know. So, but, it's interesting. It's still cool. I have pictures and I have the files, computer files and everything. And I have the 3D printed Queen, which is not the same thing, but it's similar. So, yeah. Oh, I have come to suck your blood. Uh, no, I hope you enjoyed this video. And hopefully I can see you again on this YouTube channel. Stay tuned.